Good morning, ma'am. My name is Yel Monica and I'm currently studying BTech second year in EC branch at SRIT College. Today, I will be presenting on the topic of transmission line equations, derivation and analysis, and the subject electromagnetic waves and transmission lines. First, introduction to transmission lines. A transmission line is used for the transmission of electric power from generating substation to the various distribution units. It transmits the wave of voltage and current from one end to another. The transmission line is made up of a conductor having a uniform crossing line section. Air acts as insulating or dielectric medium between the conductors. Types of transmission line. Different types of transmission line includes the following. Open wire transmission line. It consisting of pair of parallel conducting wires separated by a uniform distance. The two-wire transmission lines are very simple, low cost and easy to maintain over short distances, and these lines are used up to 100 megahertz. And the name of an open wire lines is a parallel wire transmission line system. Coaxial transmission line. The two conductors placed coaxially and filled with dielectric materials such as air, gas, or solid. The frequency increases when losses in the dielectric increases. The dielectric is polyethylene. The coaxial cable are used up to 1 GHz. Optical fiber transmission lines. The first optical fiber invented by Narendra Singh in 1952. It is made up of silicon oxide or silica, which is used to send signals over a long distances with a little loss in signal and at the speed of light. The optic fiber cables used as light guides. Imagine tools, lasers, and surgeries used for data transmission and also used in a wide variety of industries and applications. Another type of transmission lines are microstrip transmission lines. The microstrip transmission lines is a transverse electromagnetic transmission lines invented by Robert Barrett in 1950. Waveguides. Waveguides are used to transmit electromagnetic energy from one place to another place, and they are usually operating in a dominant mode. The various passive components such as filter, coupler, divider, horns, antennas, T-junctions, etc. Why do we require transmission line equation? Transmission line equation are essential for analyzing and designing transmission lines effectively. They help in understanding how electrical signals or power propagates along the line, including the effect of resistance, inductance, capacitance, and conductance. Key reasons for using transmission lines equation are: it is used to analyze voltage and current distributions, impedance matching, attenuation and signal loss calculations, reflection and transmission coefficient, standing wave ratio analysis, and to analyze phase velocity and group velocity determination. Transmission line equation. Let us take the equivalent circuit of transmission line. For this, we are going to take the equivalent circuit. Simplest form of transmission line, which is two wire lines. These two wire lines are made up of two conductors separated by a dielectric medium, usually air medium, which is shown in figure. Consider transmission line with two parallel conductors. Let the primary constant. Assume these values do not vary with frequency. Let us consider a point P on the line at the distance from the source. Let another point Q be a small distance from the point P. As shown, let us consider as shown in figure. Let V and I voltages and currents respectively at point P. Since voltage and currents are uniformly distributed along the line at point P, let the voltage be and the current be for a small length of a line. Series impedance is R plus j omega L into dx and shunt impedance is G plus j omega C dx. As we all know, the potential difference between P and Q is V minus uh, V plus dV, where V is the initial point voltage and V plus dV is the final point voltage. That is equals to I into R plus j omega L into dx. Let me consider it as a equation 1. And similarly, the current difference between P and Q is I minus I plus dV, that is equals to V into G plus j omega C into dx. This is equation 2. From equation 1, minus dV by dx equals to R plus j omega L into I. Let me consider it as a third equation. Similarly, from equation 2, minus di by dx equals to G plus j omega C into V. This is equation 4. By differentiating equation 3, that is minus dv minus d square v by dx square equals to r plus j omega l into di by dx. Substitute di by dx in above equation. D square v by dx square equals to r plus j omega l into v, g plus j omega c. Let me consider this as a fifth equation. Similarly, d square I by dx square equals to r plus j omega l into g plus j omega c into I. This is equation 6. Let the constant term at a given frequency be where Z and Y are series impedance and shunt admittance. That is gamma square equals to r plus j omega l into g plus j omega c, where gamma equals to root of r plus j omega l into g plus j omega c. Then, as we all know, z equals to r plus j omega l and y equals to g plus j omega c. Substitute gamma equals to root z into y. From equation 5 and 6, d square v by dx square equals to gamma square into v. Similarly, d square I by dx square equals to gamma square into I. The above equations are differential equations of transmission lines. The standard solution for equations are V equals to A into e power gamma x plus B into e power minus gamma x. Let's consider this as equation 7. Similarly, I equals to C into e power gamma x plus D into e power minus gamma x. This is equation 8, where A, B, C and D are the arbitrary constants. Differentiate above equations. dV by dx equals to A into gamma into e power gamma x minus gamma B into e power minus gamma x. From equation 1, Iz equals to A gamma e power gamma x minus B gamma e power minus gamma x. Substitute gamma equals to root z into y. Iz equals to root zy A into root z into y e power root z into y into x minus B root z into y e power minus root zy into x. I equals to A into root y by z e power root z by x minus B root y by z e power minus root z x zy into x. This is equation 9. Similarly, differentiate equation 8. Di by dx equals to C gamma e power gamma x plus D minus gamma e power minus gamma x. Then from equation 2, Vy equals to C gamma e power gamma x minus gamma D into e power minus gamma x. Substitute gamma equals to root z into y. Then the equation can be written as C root z into y e power root zy into x minus D root z into y e power minus root z into y into x. Then V equals to C into root z by y e power root z into y into x minus d root z by y e minus e power minus root z into y into x. Consider this equation as 10. Representing a standing wave pattern, To find the relation between V and I, substitute equation 7 in 3. Minus dV by dx equals to R plus j omega L into I. We know that V equals to A into e power gamma x plus B into e power minus gamma x. Substitute V in above equation. Minus di by dx equals to d by dx into A into e power gamma x plus B into e power minus gamma x, that is equals to R plus j omega L into I. Minus gamma A into e power gamma x minus B e power minus gamma x equals to R plus j omega L into I. I equals to B into e power minus gamma x minus A into e power gamma x root R plus j omega L into G plus j omega C divided by R plus j omega L. So I equals to root of G plus j omega C divided by R plus j omega L into B into e power minus gamma x minus A into e power gamma x. Let's consider another constant called characteristic impedance at a given frequency. Z0 equals to root of R plus j omega L divided by G plus j omega C. That is equals to root of Z by Y. Then I equals to 1 by Z0 B into e power minus gamma x minus A into e power gamma x. Let's consider this equation as 11. Similarly, V equals to A into e power gamma x plus B into e power minus gamma x. Consider this equation as 12. Write voltage and current equation in terms of hyperbolics terms. Substitute e power gamma x equals to cos h gamma x plus sin h gamma x. E power minus gamma x equals to cos h gamma x minus sin h gamma x. From equation 11 and 12, I equals to minus 1 by Z0, A sin gamma x plus B cos h gamma x. Let's consider this as equation 11. Equation 13, V equals to A cos h gamma x plus B sin h gamma x. This as equation 4, where A equals to A plus B, B equals to A minus B. The constant A and B can be obtained by applying initial conditions at x equals to 0 and V equals to Vs and I equals to Is. Vs equals to A cos h gamma of 0 plus B sin h gamma of 0. Then A equals to Vs and Is equals to minus 1 by Z0. A sin h gamma x of 0 plus B sin h gamma of 0. Then B equals to minus Z0 into Is. Substitute A and B values in 13 and 14 equations. Then the voltage and current equations can be written as V equals to Vs cos h gamma x minus Is Z0 sin h gamma x. And current equation I equals to Is cos h gamma x minus Vs by Z0 sin h gamma x. These equations are called transmission line equation. They give voltage and current at a point of distance x from the sending end in terms of source voltage and current. Thank you.